Hi learners! On this video lesson, you will learn how to find the surface area of cones. Towards the end of the video, you will have a peek at its cross-section. Determining the surface area will be demonstrated and explained in details to let you understand the concept easily. Real-life examples and applications are shown, thus making the concept relatable and meaningful. Strategies in analyzing and solving problems related to the topic are demonstrated to let you gain an understanding on how these are done so that you will be able to successfully answer geometry problems similar to these in the future. If your lesson is on solid geometry, particularly on cones, their surface area and cross-section, or if you have an assignment on this topic, or if you are preparing for a test in math, or a test in geometry in particular, or you're someone who is interested in learning math, then this video is for you. The most common real-life examples of cones or cone-shaped objects are ice cream cones, party hats, candies, sharpened pointed pencil, Christmas trees, roofs of some buildings and structures, and safety cones used in managing traffic. Cones and cone-shaped objects also occur in nature, like volcanoes, these carrots, and trees. Learners, do you have something in mind that has the shape of the cone? I'm sure you will be able to name some. As you see here, a cone is a three-dimensional closed surface or solid, having a circular base and a lateral curved surface connecting the base and the vertex or apex. On this video lesson, we will consider right circular cones only. These are the cones whose line connecting the apex and the center of the base forms a right angle with the base. This line that is drawn from the apex to the center of the base is the height of the cone. There's another height here, the slant height. This is the height of the curved surface. Another important element of the cone is the radius of the base. This is the distance from the center of the base to any point on the circumference of the circular base. Our objective today is to get the surface area of cones. Let us imagine this cone-shaped object here as a box and cut it along its length height. Opening the box gives us this net consisting of two surfaces, a circle, the base of the cone, and a sector of a circle, the lateral curved surface of the cone. The area of the two surfaces, the circle and the sector, gives us the total surface area, TSA, of the two surfaces or the net. That is, TSA is equal to area of the circle plus area of the sector. Since the circle on the net is the base of the cone, and the sector on the net is the lateral curved surface of the cone, then we have the formula for the total surface area, TSA, of the cone, which is the surface area of the base plus the surface area of the curved surface. Let us use variables to label the parts of the net and the cone for clarity and precision. Let the slant height be S and the radius be R. With the variables in place, the area of the circular base is pi r squared, while the area of the sector of the circle, which is the one representing the curved surface of the cone, is S pi r. Plugging in the values obtained, we now have the total surface area, TSA, of the right circular cone, which is pi r squared plus S pi and r, where r is the radius of the circular base and S is the slant height. Remember this, learners. to be able to solve for the surface area of the cone using this formula, you have to know the slant height S of the lateral curved surface and the radius R of the circular base of the cone. Since this is an area, the unit of measure is in square units like square meters, square centimeters, square inches, square feet, etc. Now, a word of caution in solving application problems. Some problems may need the application of the concept for the total surface area or TSA of the cone, while some may just require the lateral surface area or simply the surface area of the base. Thus, when working on a word problem, you must read it and may read it several times when needed to make sure that what you will work on is what the problem is really asking you to do. Let us do sample problem 1 so you will know how it is done. Here's the problem. The Monroe family is going to hold a birthday party for their 5-year-old daughter. The family thinks of making party hats with the shape of a cone having the dimensions shown below instead of buying them. 15 children will be on the party, including the celebrant. Part 1. If the diameter of the party hat is 18 centimeters and the slant height is 24 centimeters as shown, how much material in square centimeters is needed for a single hat? Round your answer to the nearest tenth of square centimeter. Option A, 678.5 square centimeters. Option B, 678.6 square centimeters. Option C, 687.5 square centimeters. Option D, 687.6 square centimeters. Part 2. How much material is needed in square centimeters to make the hats for all the children who will attend the party? Round your answer to the nearest tenth of a square centimeter. Option A, 10,314.0 square centimeters. Option B, 10,312.5 square centimeters. Option C, 10,179.0 square centimeters. Option D, 10,177.5 square centimeters. As usual, we begin by reading the whole problem and may read it several times when needed to know what we are looking for, to determine what are given, and to figure out how the given information help find what we are looking for. Okay, what are asked in the problem, learners? Here, we're asked to find two things. First, we're to find how much of the material in square centimeters is needed for a single cone-shaped hat. Second, we're to determine how much material is needed in square centimeters to make the hats for all the children who will attend the party. What are given? We're given the figure of the party hat with dimensions. The problem also states that there are 15 children who will be on the party. Okay, so we'll start with part 1 first. Here, we're to find the amount of material that is needed in making a single cone-shaped hat. This is the same as finding the surface area of the cone since the hat has the shape of a cone. Can you follow, learners? So let us then have the formula for the total surface area of the cone. Let's go. Now take note that the formula consists of two parts, the surface area of the circular base and the surface area of the curved surface. Learners, what do we have in our hat? Do we have the base and the curved surface? Or the base only? Or just the curved surface? Okay, so the hat consists of the curved surface only. Look at our formula, learners. Since there is only the curved surface in the hat, then we will cancel out the part of the formula that the hat does not have. We will cancel the surface area of the base. Can you follow, learners? Okay, here we go. We are now only left with the surface area of the curved surface. This is the part of the formula that will help us find the amount of material needed for a single head. Let us then write the formula. So the surface area of the curved surface is equal to S by R. By looking at the formula, the following are needed: the slant height, S, and the radius, R. The slant height, S, is given, but the radius, R, is not. So we will then get the radius first. We can get it from the given diameter. Remember that the radius is 1/2 the diameter. Now plugging in the values, we have dividing 18 centimeters by 2 gives us 9 centimeters. Thus, the radius, R, is 9 centimeters. Now, we can solve for the amount of material needed for a single head. Plugging in the values, we have multiplying 24 centimeters and 9 centimeters gives us 216 square centimeters. Multiplying 216 square centimeters to pi gives us 678.58 square centimeters. Rounding off to the nearest tenth gives us 678.6 square centimeters. So, what is our answer, learners? Is it option A, option B, option C, or option D? Okay, so the answer is option B. Thus, a single cone-shaped head needs 678.6 square centimeters of the material. That was easy. Okay, let us move on to part 2. The problem tells us that 15 children will be attending the party. So the Monroe family has to make 15 hats. From part 1, we found that the material needed to make a single hat is 678.6 square centimeters. Thus, the amount of material needed for 15 hats is 678.6 square centimeters times 15. And this is 10,179.0 square centimeters. So, what is our answer, learners? Is it option A, option B, option C, or option D? Okay, so the answer is option C. Thus, 15 hats need 10,179.0 square centimeters of the material. That was again easy. Let us go to sample problem 2. Here's the problem. A souvenir shop is designing cone-shaped giveaway items with their logo painted all over the surface of each cone to promote their brand. Each cone-shaped item will have a diameter of 3 inches and a slant height of 4.5 inches as shown. How much surface area in square inch will be painted on a single giveaway item? Round your answer to the nearest tenth of a square inch. Option A, 28.2 square inches. Option B, 28.3 square inches. Option C, 42.4 square inches. Option D, 42.5 square inches. As usual, we begin by reading the whole problem and may read it several times when needed to know what we're looking for, to determine what are given, and to figure out how the given information help find what we're looking for. Okay, what is asked in the problem, learners? Here, we're asked to find the surface area in square inch that will be painted on a single giveaway item. What are given? We're given a figure of the cone-shaped giveaway item with dimensions. Note that each giveaway item will be painted with the shop's logo all over its surface. So, getting the surface area to be painted is the same as finding the total surface area of the cone-shaped item. Can you follow, learners? So let us have the formula in solving for the total surface area of the cone. From the formula, the slant height S and the radius R are needed. The slant height S is given, but the radius is not. Just like what we did on the first problem, we have to get the radius first. We can get it from the given diameter using this relationship where the radius is 1/2 the diameter. Plugging in the value of the diameter, we have dividing 3 inches by 2 gives us 1.5 inches. Thus, the radius of the giveaway item is 1.5 inches. Now, we can solve for the total surface area of the cone to be painted. Plugging in the values, we have multiplying 1.5 inches to itself gives us 2.25 square inches. And multiplying 4.5 inches to 1.5 inches gives us 6.75 square inches. Now, multiplying pi to 2.25 square inches gives us 7.069 square inches, while multiplying 6.75 square inches to pi gives us 21.206 square inches. Adding 7.069 square inches to 21.206 square inches gives us 28.274 square inches. Rounding to the nearest tenth gives us 28.3 square inches. So, what is our answer, learners? Is it option A, option B, option C, or option D? Okay, so the answer is option B. Thus, a single cone-shaped giveaway item will have a total surface area of 28.3 square inches to be painted. There you are, learners. That was again easy. As promised, we will have a quick look on the cone's cross-sections. Recall that a cross-section of a solid is a two-dimensional surface obtained upon slicing or cutting through the solid or three-dimensional figure. Here, we will only examine the cross-section of a right circular cone obtained upon slicing it parallel to its base and perpendicular to its base. Let us investigate what shape will the cross-section be if the right circular cone shown here is sliced parallel to its base. Let's go. Okay, so slicing the right circular cone parallel to its base produces a cross-section similar to its base. Here, the base is a circle, so the shape of the cross-section is also a circle. Did you see that, learners? How about if we slice the cone from its apex going down perpendicular to its base? What do you think will be its cross-section? Okay, let's go and find out. Slicing the right circular cone from its apex going down perpendicular to its base produces a triangular cross-section. There you are, learners. I hope you acquired lots of learnings in today's video. Let us summarize what we have learned today. We have learned that, first, a cone is a three-dimensional closed surface or solid having a circular base and a curved surface connecting the base and its topmost part called the apex. Second, the total surface area of the right circular cone is pi r squared plus s pi r, where r is the radius of the circular base and s is the length height. Third, the unit of measure for the surface area is in square units like square meters, square centimeters, square inches, square feet, etc. Fourth, the cross-section of a solid or three-dimensional figure is the two-dimensional surface obtained upon slicing or cutting through the solid. The cross-section depends on the orientation of the cutting or slicing made. Fifth, when solving a problem, you must read it and may read it several times when needed to know what you're looking for, to determine what are given, and to figure out how the given information helps find what you are looking for. Sixth, when a figure is given, make use of it and modify when needed. It is there to help you analyze and solve the problem. There you are, learners. Hope this video helps. That's it for now. If you have any questions, leave a comment below. And don't forget to like, subscribe, and share this video to your peers so others will learn too. Bye.